Assalamualaikum, good afternoon. So today we are going to present our report, which is experiment 6, torsion of bar. Next. So this is the name of student, Lim Zihui, Muhammad Yusuf, Saifullah, and Hafiz Nur Izzuddin. So the table of contents. First, we have an introduction, objective, theory, working principles, experiment setup, methodology, expected result, safety procedure, conclusion, and lastly is references.
Okay, for introduction in this experiment, is a say torque is a measure of the force that can cause an bar to rotate about an axis. A solid cylindrical specimen with different material is twisted to measure the angle which the bar is twisted. The bar is used to in this experiment is nylon, aluminum, and copper.
So this is the objective. So in our experiment, we want to investigate the relationship between torque, which is T, and the angle of twist of a circular and to determine the modulus of rigidity, which is G of materials. So in this objective, we have a 3 scope that we use for our experiment to achieve the objective, which is the first is utilize 3 different type of solid bars, which is aluminium, nylon, and copper alloy. Second one is use 2 different lengths of rotation scale, which is 150 millimeter and 300 millimeter from fixed clamp. And the last one is we apply loads within the range of 5 to 40 newtons to measure the torque twist relationship.
Okay, so moving to a theory and working principle. So torque is a measure of a force that can cause an object to rotate about an axis. Just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object to acquire angular accelerations. So the below part, the two picture is like, so if we apply torque, means that we can move the steering. Next. So the magnitude of the torque vector for a torque produced by a given force is torque equals to force multiplied by angle between the force vector and the moment arm and the length of the moment arm. So as in the pictures shown here, we know that the distance is 90 degree to the force. So the sine term becomes 1, and then we get the formula torque equals to force multiplied by length of the moment arm. Next. So what is torsional shear stress? So torsional shear stress is indirect shear stress generated in a body subjected to a twisting moment. So torsional shear stress in the easy word is that body internal resistance against angular deformations causing by twisting. So below part is two formula which relate the tau and the torque. And then at the left side, and then for the right side, we can see that the formula relating the torque with the modulus of rigidity and the shear strength. Next. So what is a shear strain? So shear strain is the ratio of the change in deformation to its length perpendicular to the axis of the member due to shear stress. And shear modulus is one of several quantities for measuring the stiffness of materials. So this page explain on the shear strength. So at the right hand side we can see like this is the formula of calculating the shear strain. So C is the radius of the rod, and then which is here, and then the theta here is angle of twist, and then length of shaft. L is length of shaft. So as the shear strain is not uniform along the cross sections, it is zero at the center of twist and it is maximum at the edge of the rod. So finally, the longer the rod, the smaller the shear strain. Yeah. So when no torque is applied, the hour hand sits at 12 o'clock. As the torque is applied to the rod, it will twist and the hour hand will rotate clockwise to a new position. The angle between 2 o'clock and the 12 o'clock is referred to as the angle of twist. Next. So this is the formula, and then after derive all this relationship between the torque and the tau, and then the tau and the modulus of rigidity and shear strain, and then the shear strain formula. After we derive, we get the final formula for our experiment, and then this one is the angle of twist, which is measured in radians, and then the torque exerted on the shaft, and then this is the length of the shaft, and this is polar moment of inertials, and this one is modulus of rigidity. So this is how we calculate the polar moment of inertia. So if we're using solid rod, the inner radius is equal to 0, and if we use hollow rod, so the external and the inner radius, we have to minus it. So we take the external radius minus the inner radius. So in these equations, J denotes the second polar moment of area of the cross sections. This is sometimes referred to as the second moment of inertia. Next.
So for the experiment setup, the apparatus that we use in this experiment. Next. First we have a torsion bus testing machine, and screwdriver, load 5 Newton and load hanging. Next we have aluminum bar, copper bar, nylon bar, and digital caliper. And lastly we have ruler 1 meter. Proceed next. So for methodology, first we have to prepare the apparatus in diagram 1, the all apparatus, and measure the diameter of torsion bar testing machine, nylon, aluminum, and copper bar. In diagram, okay, for next, the second step, we have the copper bar is clamped in position, diagram 5, and the load hanger is placed on the cord, diagram 7. Okay, the third step is the rotation scale is set at 150 mm from the fixed clamp, and the pointer is set to 0, diagram 8, 9, and 10. And the fourth step is a load of 40 Newton by 5 Newton increment are at diagram 11, and the twist of the specimen of each increment are recorded in table 1, diagram 12 and 13. Okay, and the fifth step is the load is removed and the rotation scale was pointed to 0, and distance from fixed clamp was set at 300 mm from the fixed clamp, diagram 40. And the sixth step is the same procedure will repeat for 300 mm length between the rotation scale and pointer and the fixed clamp. The specimen will change to nylon bar and followed by aluminum bar. The rotation scale and pointer was set to 150 mm. And last step is step 4 will repeat for nylon bar followed by aluminum bar. The result will fill in the table 2 and table 3.
Okay,
This is the experimental result. As we can see, copper, we have a torque of Newton millimeter, and then the twist of the rod was recorded after the experiment have done. So we have changed the twist of rod into the radian. Next, we have aluminium. Also have the same method on how to calculate the twist of rod in radian when we get the angle during the experiment. And last, we have nylon. Also, we have only for nylon we have a different load, which is 5 Newton into until 12 Newton, and we have the twist of rod in degree, then twist of rod in radian. So this is the calculation to find the torque. As we know, torque equal to R, which is radius, multiplied by force. So we have the distance for the circle at the fixed point, which is 77.98. So to get the radius, we need to divide by 2. Then we have force for copper and aluminium, which is 5 Newton until 40 Newton, increase by 5 Newton for each experiment. Then we have a nylon from 5 Newton until 12 Newton. Then we also have the calculation to find the moment of inertia. We know the moment of inertia equal to pi r4 over 2. So yes, just use the formula and substitute all the values so we can get the value of moment inertia for copper, aluminum, and nylon. So this is the table and the graph. The table is for copper 150 millimeter and 300 millimeter. So this is the graph for copper 150 millimeter and 300 millimeter. And this is the table for aluminium 300 millimeter and nylon 300 millimeter. So this is the table: aluminium with 300 millimeter and nylon with 300 millimeter. This graph, we know that in radian against the ITL over J. So after that, we can find the rigidity of the material. First of all, we need to find the gradient. To find the gradient, we can use the formula y2 minus y1 over x2 minus x1. So you can find the gradient. After you find the gradient, you can find the rigidity of the material, which is 1 over gradient, 1 over g. I'm sorry, 1 over gradient. So you can find the value of g. Then the small table here, we can use as our reference based on our website that we found in the internet. We can see that copper have rigidity 45 kilonewton mm, aluminum 27, and nylon 4.1. So this is our discussion on our experiment. To what extent does the experiment verify the TL over J divided by twist, which is radian in radian, formula based on the graph plotted? The angle radian of the twist is actually directly proportional to TL over J. As we can see just now, the graph is constantly increase when the radian increase, and TL over J increase. So the larger the torque applied to the shaft, the larger the angle of the twist of the shaft. And all the shaft exhibit purely elastic behavior, as they can twist when we apply the force. So we can conclude that from the graph can verify that the angle of the twist increase when the torque increase. So about the comparison between three different type of bar and different length of the rotation, scale and pointer from the fixed clamp. So from this table, we can conclude that when the distance between the fixed clamp increase, the rotation uh, of the material of the bar also increase. As we can see, at 100 for copper at 150 millimeter, the twist of the rod equal to 0.5, and at 300, 0.01. So for different material, if the rigidity of the material have higher rigidity, so the twist of the rod uh, not easy to twist. For example, copper have higher rigidity compared to the nylon. So the twist of the copper at 300 millimeter is small compared to the twist of nylon at 300 millimeter, which is 17 degree. So the last discussion is based on your finding. Explain the relationship between the model's rigidity of the material of with the parameters such as type of material for the bar, length of the bar, the type of material of the bar, and polar moment of inertia. So this is the result that we get to find the rigidity of the material, which is for copper 56 56,777.86 Newton meter, and that's the value for 150 millimeter, and copper 300 millimeter. We can get the value of rigidity is 43,956.04. Aluminium for 300 millimeter is 67,796.61. Nylon 5,738.4. So based on the question, we found that the result from the experimental are not verified with the rigidity formula. This is because the result obtained are not the same with the theoretical result due to the some error during the experiment that we conduct in the lab. So this is some of the possibility error that we have done during the experiment. First, parallax error during the taking of measurement for the length of the shaft, and also during the measuring of the rotation of the rod using the arc shape scale. This is some key because maybe during the experiment our eye is not really perpendicular to the scale reading. So the second is this is because the specimen used is not exactly 100% pure of might and might contain some impurities in it. This is because some of the condition of the load might have the defect or something, any impurities on the load. And the third, the specimen malformation may also occur. For example, when we have two 5 newtons load, and when we put the hanging, it is not really accurate, equal to 10 newton. And other than that, there are also had zero error, which is okay when the reading on the scale is not starting from the zero value.
So for the safety procedure, as a requirement for us to went to the lab, first we need to wear a proper PPE, which is a lab coat and safety shoes, which is why we need to wear our lab coat when conducting the experiment is we want to protect our skin and personal clothing from incidental contact and small splashes while do the experiment. And we want to prevent the spread of contamination outside the lab and to provide a removable barrier in the event of the incident involving a spill or splash of hazardous substances. And the reason why we need to wear our shoes, our safety shoes, while conducting the lab, is to protect our foot from foot injury, which is most of common causes, which include the crushing, impact, and puncture. Next. So this is a precautionary step that we need by conducting the experiment, which is first we need to zero out the caliper before start the experiment. The reason is we need a proper zero before begin the experiment is to make sure the reading that we get was accurate. And the second one is clamp the jaw around the outside of the object for an external measurement. And the third one is make sure lock the screw after measure the object, because we don't want the object that we measured was moving. And the last one is look at the digital reading. And so based on the picture here, we have the way to measure the object, which is the right one, and the green, which is the wrong one, is the right one. Next. So these are the loads that we handle in our experiment. So we need to make sure that we handle it carefully while conducting the experiment to prevent any injury. And while reading the rotation scale, make sure the cable at 0 degree and your eye should place perpendicular to the reading to get an accurate value. Next.
Okay, so for the conclusion, in this experiment, we can conclude that torque and the angle of twist of circular section specimen is directly proportional to each other. Besides that, the angle of twist also proportional to the length of shaft, and the relationship between torque and angle of twist obey the equations below. So the equations is valid to determine the modulus of rigidity of any materials from the experiment value of rigidity for copper rod, aluminum rod, and nylon rod are this value respectively. Next. So this is our reference. Thank you.